At each corner of a square of side D, there are these positive point charges of magnitude Q, 2Q, 3Q, and 4Q. And we're going to solve for some forces, expressing all answers in terms of Q and D and physical constants. And in this case, the physical constant we're talking about is the Coulomb constant, K, that one that is equal to 9.0 times 10 to the ninth. So part A, determine the magnitude of the force of charge 2Q on charge 2Q due to charge Q. So we want to find out how much force is being exerted on this charge due to this charge. So we're just going to ignore these two down here and just write out Coulomb's law. F is equal to K, Q1, which is Q, Q2, which is 2Q, divided by the distance between them squared, and that would just simplify to 2K Q squared over D squared. That's all there is to these kind of questions. Part B, determine the magnitude on that same charge, 2Q, now due to this charge, 3Q. So the force is going to be equal to K times the two charges are 2Q and 3Q divided by D squared, which gives you an answer of 6. K Q squared D squared. Part C, determine the magnitude of the force on charge 2Q due to 4Q. So the force is equal to K times 2Q times 4Q divided by, but now what the hint in this problem is saying is that the distance between these two charges is not D, the way it was between these two charges or between these two charges. So we've got to figure out the distance between them from here to here. And that can be done either using the Pythagorean theorem, the square root of D squared plus D squared, or if you remember the properties of the special right triangles from geometry, this is a 45, 45, 90 triangle, and that hypotenuse of that triangle is just equal to the square root of 2 times D. So that is what is going to get squared. Square root of 2 times D, that whole quantity squared. So in the numerator, you've got 8kq squared. In the denominator, the square root of 2 squared becomes 2. And so when you divide them out, you'll get 4kq squared over D squared. So part D is just saying that if you were to add this plus this plus this, they have all the same coefficients, or all the same, everything is the same except the coefficients, the 2, the 6, and the 4. And if you add them together, you get 12 kq squared over D squared. But that's not the magnitude of the net electrostatic force on charge 2Q. Even though we figured out the charge due to each of the three charges, why is that not the charge on 2Q? And it's a pretty simple reason, and it comes down to the fact that forces are vectors. If forces were scalars, then you could just add the numbers together and you would get this as your answer. But since forces are vectors, they're not all in the same direction. Like the force due to charge Q exerts a force this way, away from it, because they're both positive charges, they repel each other. The force due to charge 3 exerts a force upward, and the force due to charge 4 exerts a force in that direction. So because we're dealing with multiple directions, we cannot simply just add the forces together. And finally, in part E, draw a single arrow representing the approximate direction of the net electrostatic force on charge 2Q due to the other three charges. So I've already drawn arrows from each charge individually. So we know the net overall force is going to be somewhere up in this region because it's being pushed to the right and it's being pushed up and then it's being pushed to the right and up. But we've really got to think about which of these forces is going to be bigger. And if we compare these three numbers, Well, it turns out the force due to charge 3Q is the biggest. That's got a 6. So think of this upward arrow as the biggest, and then the charge due to Q is the smallest, so the arrow to the right is the smallest, and then this diagonal one is the one kind of in the middle. So if we were to combine those three together, that would give you an overall net force. Instead of pointing at a perfect 45-degree angle, like this one, the upward force is bigger than the rightward force, so that's just going to shift the arrow kind of upward a little bit. So your final arrow should be kind of pointing in that northeast direction, but a little bit bigger than 45 degrees, maybe like around 60-ish degrees or so. You don't have to get the exact angle on it as long as you have the arrow kind of pointing in that approximate direction.